All right, good morning, guys. Miss Jones here. I hope that you're all doing well. I miss you guys, and I really am looking forward to being back in the classroom with you. This is our last lesson for this week before we are officially on spring break. Tomorrow will be a work day, review day, and I will also be hosting a Zoom conference at 12 o'clock tomorrow. So if you have any questions tomorrow, which is Thursday at 12, I will put a link in the module in Canvas, and I hope that you all can join. Bring any questions you have, and we can work them out together. All right, so for our lesson today, we are doing a part 2 from yesterday. We're just adding to that, and we're going to practice writing more equations for trend lines so that we can make predictions. And please know that your Edulastic today will be questions based off of this, and you won't have a paper assignment that you'll have from me. So let's talk about the scatter plot first. So when I take a look at the scatter plot, I have one outlier. I have one point that is not following what the rest of my points are doing. And when I draw a breadstick or a pickle around my data, I have a strong positive association. The reason it's a strong positive association is because I have a positive slope, and as the years increase, so does the age. So my points are going up. It's strong positive. If my points were going in a direction somewhat like this, that would be a weak positive correlation or association, because this is not a positive slope that is strongly positive. So let's practice writing an equation for our line. And so the first thing that we're going to look at is our slope. So remember that your slope is your change in y over change in x, and I'm going to draw an XY chart for that. So my X is my years since 2000, and my Y is my average cost. So I'm going to use 2 points for my graph. The first point I'm going to use is 0, 2.6, and the second point I'm going to pick from my graph is 6, 2.9. And when you are finding your slope, you must pick 2 points that are on your line to get the best equation. You must pick 2 points on your line. So let's find my change in y. So I will subtract 2.9 minus 2.6 to find the difference, and that is a positive 0.3. And to get from 0 to 6, we just have 6 minus 0, which is 6. Okay, now I want to write my slope as a fraction, so I've got $0.3 or 30 cents per every 6 years. Now what that means is that the average cost per year, or per 6 years actually, is going up by 30 cents. This is the same as 30 cents. Now I want to know what is my average cost per every 1 year. So to figure that out, I will divide my numerator and denominator by 6 so that my denominator is 1. So if I divide 30 cents, I would get 5 cents. And 6 divided by 6 is 1. So my slope, or my M, is 5 cents per every 1 year. Remember that for slope, we always use the word per. Okay, now that we've got our slope, we want to eyeball our graph and figure out where we begin. So on my graph, at 0 years, the average cost is $2.6 or $2.60. So my B is that at 0 years, the average cost is $2.60. Okay, so here's my equation. The average cost, which is y, because y is my y-axis, is going to be my slope, y equals mx plus b. That's how we write an equation for a line. So that's going to be my 5 cents per every 1 year. my X is my years. And then I'm going to add that to the $2.60, which is my beginning average cost. Okay, so that's my equation for that line. And that is the equation that I could use to make predictions for any part of this situation, any part of this graph that's not pictured. All right, nicely done. We are going to do one more example today. All right, for example number 2, I have no outliers, and if I draw a pickle around my data or a breadstick, I can see that this is probably a weak positive correlation, a weak positive association. And one thing I want to note is that I use correlation and association interchangeably. They are the same meaning, they're the same word meaning, they have the same word meaning, and what that is relationship. So a correlation is a relationship, an association is a relationship. So if I say that this is a weak positive association, then that means that my slope is not going up steeply, and this is not really a super strong relationship between my years since 1998 and my graduation rate. If this was a strong positive association, my points would be probably falling more of something like that direction where I have a steeper positive slope. Okay, so let's jump in and write our equation for this line so that we can make predictions. If I were to ask you to make a prediction about how many people graduated in 8 years after 1998, then that would most likely be about 71%. That would be my guess. But we want to know how to make predictions for things that are off of our graph or things that we don't have pictured. We want to be able to make predictions for them. So I'm going to first think about my equation for a line, which is always y equals mx plus b. And my m and my b represent, first off, my b represents what is the graduation rate beginning amount. And then my slope represents the graduation rate percent per year since 1998. Okay, so I'm first going to find my slope. So I'm going to pick 2 points. X is years since 1998, and Y is my graduation rate percent. So I must pick 2 points that my line goes through. So I'm going to pick 1, 60, and I'm going to pick 871. Okay, once I've got my 2 points picked, I'm going to count my slope. So to find my change from 60 to 71, I'll just take 71 minus 60, which is a positive 11. So there are 11 between 60 and 61, and that is a percent. And then 1 to 8, 8 minus 1 is 7. Okay, so what this means is that there is an 11% increase in graduation rate per every 7 years. Now, again, with slope, we want to know how much of a percentage we have per 1 year. So to figure that out, we're going to divide our numerator and denominator by 7 over 7. And I'm going to pull out my calculator for this. So 11 divided by 7 is 1.6. I'm going to round to the tenths place. So 1.6%. And 7 divided by 7 is 1. So 1.6% per every 1 year. So that's my slope. M equals 1.6% per every 1 year. So that's how many more people graduate per year. You see a 1.7% increase per year. Okay, now that I have my slope, I want to find B, but as you can see, I don't know exactly what my beginning value is because I have an arrow drawn through where I would begin, but I don't know that exact number. So I'm going to show you how to find B without exactly seeing where a line goes through. So as of right now, I have y equals my 1.6% per year times my number of years plus where I begin. Now I need to figure out where I begin, so I'm going to figure that out by using my point from my graph. And the point I'm going to choose that my line goes through is 1, 60. 1, 60. Now, I recommend always picking the easiest point possible that your line goes through on your graph. X is 1, Y is 60. So I'm going to substitute my X and Y with that point. So when I rewrite the problem, I have 60 equals 1.6 times 1 plus B. Now I'm going to draw my line through my equal sign to solve for B since I'm used to that. I know that 1.6 times 1 is the same as a positive 1.6. Now my last step to solve for B is that I will just subtract 1.6 from each side. And what I would get is 58.4 equals B. And what does that mean? What does that mean about where I begin? Well, what that means is that at 0 years, so in 1998, the graduation rate is 58.4%. And then after 1998, we start increasing by a rate of 1.6% in graduation rate per year. So my equation is this: y equals 1.6 times x plus where I began, 58.4%. All right, so that is all for today. I will most likely add one more from the edge elastic because I do suspect there will be a few questions with that one. Go ahead now and log into your edge elastic. If you need help with that, then let me know and I will make sure that I help you get logged in and everything. Thank you guys for listening. I hope you have a wonderful day and I will talk to you guys later. Bye.